This video is a part of my full digital guitar pedal building course. In this video, I'll teach you the basics of KiCad and how to make a circuit schematic that will match up to where we are at right now with the Daisy. By the end, you'll have your whole custom circuit diagram written out. This course is also sponsored by PCBWay, a quick, cheap, and well-made solution for getting PCBs custom manufactured. I'll show you how to order through them later in the course, so stay tuned for that. So what exactly is a PCB and why would we want to make it for a guitar pedal? Here you can see I have a couple different pedals and you can see the PCBs in here, which stands for printed circuit board. So far in this course, we've been using a breadboard to do all of our routing, which to do it, we would have to put the seed down and then say we put a knob, we then have to connect every single pin with wires. And that both takes up time and it takes up a lot of space. So obviously if I wanted to put this inside of there, we would have wires flying all over the place and it would be such a hassle. With the PCB, we are able to specifically do all of the routing within a software and then cater each PCB to a specific circuit. So as you can see here, we have the 2 rows of 20 pins for the Daisy. These are for the pots here, and then the foot switch and everything. And so all we'll have to do is solder on the parts and not have to worry about the routing at all. Here you can see in all the pedals you get, this one's just the Electro-Harmonix Big Muff. You turn it around and you can just see the PCB right in there and all their parts, which is a pretty cool way when you're starting off to just see how some of these pedals look. Here's an example of one without a PCB. This is one of the first pedals I ever did, and it was made on one of these proto boards, which is technically a PCB, but it's just not a specific one with a circuit. And we can see all of these wires in here and this horrible, ugly soldering that I grouped up everything. I really had no idea what I was doing, but yeah, it was a little bit of a hassle to do, always a hassle to fit it inside. And so making a PCB makes it so we can just have everything sitting nice inside of there. You can see here I still have all these wires, and that's just because I didn't use PCB mounted jacks and foot switches and stuff, just because when you're starting out it's a little easier to not have to worry that deeply about space, but it is a nice way in the future to get it so your builds can be much smaller. Another great thing with PCBs is that they end up actually being quite cheap. We're going to be designing 2-layer PCBs, and on PCBWay each one is only going to be $1. You can't order a single one, so you have to order in 5s, and there'll obviously be shipping. Typically the sort of global shipping is around $5, so it'll be 5 for about $10, but that's an excellent price. And if you want to buy maybe 10 and make 10 pedals, then the price will only get cheaper as the shipping price will get dispersed through all of those. The software I'm going to be using to design our PCB is KiCad or KiCad. This is a great open source software, so it's a great place to start, and you can just search KiCad and download it here. Depending on when you watch this, there might be new releases. I'm going to be using KiCad 8 because it's what I've been using, and honestly most of what we're going to be doing is a lot of the sort of primitive features, so I don't expect it to really change a lot if you're in a later version. So once you're in KiCad, you can come up here and hit new project. I'll just name this chorus pedal. So it might be kind of confusing at first. There's a lot of sort of random symbols, and we're going to get to some of it, a good amount of it. But for now, the main thing that we are going to be doing is adding symbols. There's a few kind of terms in PCB design, especially with the circuits. There are symbols and footprints. Symbols are the actual symbol that we'll use in the schematic here, and then footprints are the sort of pin layout that we will have on the PCB itself. So like for our 3-pin knob, that will have a footprint with the specific spacing that the datasheet tells us, and we can either make those or find them online. I'll show you how to do both. So to start, you can hit A. This is where we're going to find all of our symbols. They have a huge library of kind of all of the typical parts, and luckily for us, even some very specific microcontrollers like the Daisy seed. So you can just come here, search Daisy seed, and it should pop up right there. This was added in some recent year. I'm not really sure, so it might not be there if you have an earlier version, but you can always just Google it and find it online. So then you will get to place it. I'm just going to place it up in the corner here, hit escape, and now we have the Daisy. So hopefully by now you are able to somewhat recognize what exactly this is, but this is just this exact pinout right here, just sort of organized in a way that's a little more helpful for designing our actual schematic. But as you can see, we have like VIN, which is up here, and that says pin 39, and then down here we see VIN is 39, and that'll just be true for everything. So nicely they have all the power at the top and then the 2 ground pins at the bottom, which is why this is laid out that way, but you'll see that the actual numbers just totally coordinate with this pinout right here, which I do recommend just going forth with designing this, that you have this photo open somewhere, because we will be referring to it a pretty good amount. So next, we probably just want to add all of our symbols, since by now we sort of know what exactly we want. In my case, I have 3 knobs, a foot switch, and an LED. And then with that LED, you will need a resistor. Typically 1K works good for a daisy, so I'm just going to do that. So if I hit A, I can search potentiometer, and then this is where you will want to sort of go through and make sure it's exactly what you need. We know that the potentiometers we've been using, they have 3 legs. So right here, we can see that this will probably work just fine. And then I could just go 1, 2, 3. I'll explain what everything means about this once we get all of our symbols set up. But next, I'm going to go and just search for an LED, and there we have, that's sort of the default LED symbol. Then I'm going to go and get a resistor. Going to use this US one because it's what I know. You can hit R to rotate, so I can just immediately line this up with the resistor right there. Make sure the resistor is attached to the correct side of the LED or your circuit won't work. So here it should be on the side where that arrow is pointing. And then next, I'm going to search for a switch. There are typically many different types of switches that, as you can see, will have so many more basically switches within it. Your typical one will be the SPST, single pole, single throw. So make sure that that's the part you bought, if that's the one you're wanting, if it's just an on-off sort of switch, or if you ended up buying a different one, then you can find a symbol that matches that. But I'm going to just do the SPST. The other things we'll be needing are the audio jacks. So I'm just going to type audio jack, and here it is. So we're just going to place 2 of those down, and then we'll just need our DC jack, and I'm just going to place that up here. So a couple quick things about KiCad. One thing that's sort of specific to KiCad is when you zoom with your mouse, it'll zoom from wherever that point is. So you can see I'll place this, and now I will kind of jump over there and zoom into that. It's actually quite handy, to be honest. And then also, when you want to select a specific object or like move it or something, there are all these shortcuts, and if you just hover over it and I press M, for example, I will now just be moving that exact object or symbol that you were hovered over. Same thing with like E to edit. So you don't have to click and then hit E, you can just hover over something and click it. And say if you're moving, for example, I can hit escape and it'll just pop right back to where it was. So I'm not really going to get into much circuit analysis or really explaining much, because honestly, we had already sort of done all of this. We already routed everything on the breadboard, and we're going to do just exactly that once again. So I'm just going to show you how exactly we route things, how we can connect all of these wires without needing to draw them all around the screen here. So we could just start over here with the daisy. First thing we can do is sort of just define that these are our ground, and there are some nice symbols to do that. So if we hit A, you can actually search for ground, GND, and there will be a symbol for that. So then here we are with ground. I can just connect both of these to that. So now these are both connected, and then that means that whenever we place another ground, that will also be connected to this right here. So now I can come over to these pots, and if you remember, there's those 3 pins, the middle one being the one that goes into the daisy, and that just goes exactly like left to right here. So 3 was the one on the left, 2 is the wiper, the middle one, and then 1 is that one on the right. It's not a huge deal if you put them sort of backwards or anything. You can always in the code just invert the way the knob turns or anything, so you don't have to worry about it that much. But I'm going to connect all of these downwards to a ground pin. So then here, those connect up. That just means that these are all connected. I can hit A, ground, and connect that right there. And then this top part, if you remember, actually gets connected to this 3v3A. So we're gonna need some sort of way to make sure that we can get this signal over here. So over here, let's see and search if they have a 3v3. Yep, here it is, and then I can just connect that right there. The shortcut to get the wire tool is W, but that will start creating a wire from right where you hit W, or you can also just hit escape, and then if you hover over here, it'll start to draw a wire. So I'm gonna make sure I leave some space because the wipers we're going to have coming out a bit. So if I bring one out there, you can then double click, and then I can bring another wire there, and then our last wire there. So those are all connected, and then we can get that 3v3 back. Oops. And now those are all connected to the 3v3. So the next thing we can do is connect these audio jacks. You can see here there's an S and a T. This just stands for sleeve and tip. Sleeve is typically ground and tip is our actual signal. This is also a way that you can look on your jack to know which one is ground or sleeve. You can Google that and it should pop up. But yeah, we want our tip to actually go into our audio out. So I'm going to do the ones as that. So there is one. It is nice to try and keep things a little straight. So then we're going to put the audio in one there. Probably going to move this back just a little bit so I can add our grounds here once again, and then we can rotate that around. So boom, boom. And now our jacks are connected. So next we can do our jack. This symbol right here usually means ground, so I can put the ground there. And if you ever see a symbol you don't know, you can easily, like here, you could Google DC jack symbol meaning or something and it should pop up. And then I'm going to connect that to our V in. Up to this point, you might have not actually used a DC jack yet to turn on the Daisy, but obviously if we're making a pedal, you don't want to hook up a micro USB or something into the Daisy. So we're going to be actually mounting a jack on there, and you just hook that up to the V in and then ground. You can see here on the Daisy C data sheet, we have the V in range, which is at minimum 5 volts and maximum is all the way up to 17 volts. So your typical like 9 or 12 volt power supplies for pedal boards or anything will work totally fine with this. I always just use some random 9 volt power adapters I have lying around. So yeah, you can just hook those up right there. So another thing we need to do is connect the LED and the switch to ground. So here I can just put ground there and then ground on the LED there. And then all of these remaining pins like on the pot and this resistor and here are all just going to be going to specific ADC or digital pins on the Daisy. Now this is something that for now we can have it routed to a specific place, but honestly you will probably end up changing this to help out with your PCB later, because you'll find that when you place parts in specific ways, then some will be closer to certain, say, ADC pins than others. And so you'll want to just minimize the length of all of your sort of routing. And so we'll want to put that later to the most optimal position. But for now, we can just sort of put them in a standard place so we can get our actual routing worked out. So like I'm just going to put these 3 pots to ADC 0, 1, and 2. And how we do this instead of drawing this huge wire all the way over there is we can use labels. So you can see this A with an underline. The shortcut is L. And if I tap L, we'll get this little prompt where we can type in label names. So I'm just going to say pot 1, and then I can just attach that right to any of these ADCs. So I click it and then that little circle disappears. So that means that this connection is now pot 1, meaning any wire that we then put that label to, those will be connected and that will also be pot 1. So then I can come over here, click again, type in pot 1, and then we get that and boom. So now these are connected. You can see that right here when I click pot 1, it says connection name. So that means if I were to draw sort of any wire coming out of here and then click it, you'll see the connection name is pot 1. So now we can go through. I'm going to do pot 2 and place that there, and then I can do pot 3, place that there, and then I can come over here again and say pot 2, pot 3. So now all of our pots are connected and we can just do the same thing for the switch and LED. So I just have connected those sequentially because like I said, we'll probably change that, but maybe just for now connect them to something that you know is at least correct, like the foot switch and LED. It says the ADC 3 and 4, but we're actually connecting those to the, like in this case, D18 and D19, but it doesn't matter a whole bunch at this point. So all the remaining stuff we have to do is pretty much just trying to tell KiCad, our software, what our circuit exactly is. So there's all these things that we can tell KiCad so that it can tell us whether we have things correct or not. Because there is this really nice helpful feature called the electrical rules checker right here, which I can hit run and it will try and tell us if there are any errors in our circuit. And as you can see, it is telling us there are a lot, but it's kind of confusing because we pretty much routed everything perfectly. But we can see here it is yelling about all of these, and let's see what those exact errors are saying. Pin not connected. So it's yelling at us for all these pins that we don't have connected, which is kind of annoying because we don't even want these connected, but they do have a way where we can tell KiCad, hey, we don't need these connected, and that is this little no connect flag, which you can just hit Q. So I can hit Q and it will just place it right where you are. So don't do that, I suppose, but you can just go over all of these and hit Q on them. All right, so I have X's on everything. Let's see what it is still yelling at. So it says input power pin not driven by any output power pins. We can see those two arrows on the ground here and the V in. This is basically happening because the software knows that this V in and ground should be having some sort of output power, and we haven't exactly told it that this jack right here is that power, and we need to explicitly do that. So I can come here and just hit A, and then you can type in PWR, and this power flag will pop up, and then we can just connect that to both this V in and the ground. And I know it's getting a little cluttered. You can always come and hit M on the actual text to move it around, or I can obviously just move this jack backwards. So there we go. Now we have told the software that this is some external power, and those errors go away. So now we're almost done, but there is one last thing we need to do. So we told the software here with the power flag that this is power, but this is only for that ERC checker. But we will need another way to tell the software which connections are power, because something like the V in from the DC jack is going to be carrying a lot more current than, say, our foot switch right here. And when it comes to designing the PCB, if something has a higher current, that will need to have a bigger connection width. We'll talk more about that later when it comes to making the PCB, what exactly tracks and things are. But for now, we just need to make our power net class. A net class is KiCad's way of being able to group together these connections. So I can come and hit File Schematic Setup, then come to Net Classes. Then we can hit the plus and just say Power. Next, if you come over to this A right here, you can hit that and then select the Power Net class. And then we can just hit that on both this V in, and then we will want to add it to the 3v3, which I'm going to extend this out just so it looks a little less cluttered. So there we go. Now, if I click this wire, you can see down here we have the resolved net class of power. And that's pretty much it for the schematic. This is obviously a very simple circuit. We added pretty much nothing else except the bare minimum of what we need to get everything running. I definitely implore you to go search more and learn so much more about circuit design and things. It is a little over the scope of this course because I'm just trying to teach you how we can get this bare basic pedal where you can start programming everything. But there's a lot of room for stuff here. A great way to learn is look at other people's projects. There are things like even Daisy stuff like the Daisy pedal or that terrarium PCB I mentioned, or there's other open source projects where you can go and just look at people's schematics. So for example, here are the build documents for the terrarium PCB, and we can see here this is their schematic. And there's a lot more going on because obviously they have more switches and things, but also they have all these little circuits which are in between typically just the jacks and into the Daisy, and then your DC jack and into the Daisy. These are things that are just going to help with voltage regulation and noise suppression, which is definitely a must if you're trying to sell a lot of these or really try and make them as professional as it can be. But for now, this will totally work and was pretty easy to set up.
You're halfway through the course. That's wonderful.
Hopefully by now you have a very basic understanding of KiCad and have your circuit diagram built up. In the next episode, I'll teach you how to make and assign footprints to your PCB so we can make sure our PCB and our schematic connect. The playlist for the full build is linked below. I'll see you there.